Hello students, today I will discuss a new topic which is in your inorganic chemistry syllabus, that is group 16 elements. So the group 16, if I will look at the periodic table, then we can say that the group number 1 and 2, that is the S block element, and from group number 13 to group number 18, that is our P block element, and in between them the elements that are actually known as the D and F block elements. Okay, so group 16, that means that is included in your P block elements. So what are the elements are there in group 16? At the top, the element that is oxygen. Just below of oxygen, the element is sulfur, next selenium, next tellurium, and the last one, that is the polonium. So out of these 5 elements in group 16, only oxygen, that is the gas, and that is most abundant in nature, and the other, that is sulfur, selenium, tellurium, and polonium, these are all solids. And most interestingly, the polonium is the least abundant element, and the polonium, that is actually radioactive. Okay, that is a radioactive element. Now the oxygen and the sulfur, that is the non-metals in group 16, the selenium and tellurium, that is metalloids in group 16 elements, and the last one, that is the polonium, that is metal, so that is the radioactive metal. Okay, so that is all about the group 16. If you have the periodic table, you just look at the group 16, and from top to bottom you can observe these 5 elements are there in group 16, that is oxygen, sulfur, selenium, tellurium, and polonium. Now these elements, that is from oxygen to tellurium, that is oxygen, sulfur, selenium, and tellurium, these are all known as the chalcogens or ore forming elements. Okay, everybody we know that the group 17 is known as the halogens. Group 15 I have already told, that is known as the pnictogen. Group 18, that is the noble gas elements. Like that, group 1, that is alkali metal, group 2, that is alkaline earth metal. So like that, the group 16, that is known as the chalcogens, means not all the 5 elements, only from oxygen to tellurium, that is oxygen, sulfur, selenium, and tellurium, these 4 elements are collectively known as chalcogens, or which means that ore forming elements. Okay, now we are going to show few trend, like the trend of the radius and the trend of ionization energy, the trend of the electronegativity, the trend of density, melting point, boiling point, like that. So from oxygen to polonium, the radius or the radii, that actually increases. Okay, as because we know that if I will go if I will go from top to bottom along a group, then the size is increasing. So oxygen जो है इसका size जो है, that is less, and then the sulfur and selenium, they are almost similar in size, and then after that, after the selenium, the element is tellurium, that is slightly higher in radius, and then after that the polonium, that is also slightly higher in radius. And obviously the ionization energy trend, that is actually opposite of the radius. So in case of the oxygen, the ionization energy is maximum, and in case of polonium, the fast ionization energy, that is least. Okay, the reason of oxygen, why the fast ionization energy of oxygen, that is high, The main reason is that the size of oxygen that is less, and for that reason the outermost electron and the nucleus, in between them the attraction is very high in case of the oxygen. So if we want to lose or if I want to remove one electron from the outermost shell of the oxygen, that requires high amount of energy, and for that reason the first ionization energy of oxygen that is high, and it gradually decreases along the group. Next, the electronegativity trend, that is also very important to know. Everybody know that the fluorine, oxygen, nitrogen, chlorine, these are all most electronegative elements. So oxygen is there at first, then the most electronegative is selenium, next is sulfur, next is tellurium, and last one, that is the polonium. And if I want to look at the density, the oxygen is least dense because that is gas. Obviously the density of oxygen, it should be less, then the sulfur, then selenium, then tellurium, and finally the last one, that is the polonium, that is actually metal, and for that reason the density of polonium, that is maximum. Next, the melting point and boiling point. The melting point and boiling point, oxygen is gas, so obviously the melting point and boiling point, that is very less in case of oxygen, and then the sulfur, then selenium, then polonium, then tellurium. That is the trend of melting point and boiling point of group 16 elements. The large difference between melting point and boiling point of oxygen and sulfur is because the oxygen is diatomic gas, but sulfur exists as S8 molecules. Okay, so there is a large difference in between the melting point and boiling point of oxygen and sulfur. The main reason is that the oxygen is a diatomic gas, so for any type of the gas, obviously the melting point and boiling point, that is very less, but in case of sulfur exists as S8 molecules, which is also known as the crown like structure. So due to that structure, the sulfur is very stable and it exists as octaatomic state, means S8, and due to that reason the melting point and boiling point, that is very high in case of the sulfur. So there is a large difference in between the oxygen and sulfur's melting point and boiling point. Next, the metallic character. At first we have already told that the polonium is metal in group 16 and oxygen is gaseous, and in between the sulfur, selenium and tellurium, okay, these are actually the metalloids. So obviously the metallic character, first the maximum, that is polonium, next tellurium, next selenium, next sulfur, and then oxygen. The selenium and tellurium, they are also octaatomic in nature like sulfur. So sulfur exists as S8 molecules, and similarly the selenium and tellurium, they are also octaatomic in nature, that is Ac8 and P8. Okay, they are also octaatomic in nature. Next, little bit information is there for the oxidation state. All the elements in group 16 except oxygen show -2 to +6 oxidation state. So except oxygen, the other elements, that is sulfur, selenium, tellurium and polonium, they show the -2, +2, +4 and +6 oxidation state. Oxygen never shows positive oxidation state except with fluorine. So in case of the oxygen, we can check that all the oxidation state of oxygen, that is in negative. Okay, so it never shows +1 oxidation state except with fluorine. Okay, so the main reason is that the oxygen, the electronegativity of oxygen is very high, and for that reason it never shows the plus oxidation state, it always shows minus oxidation state. But when it forms compound with fluorine, it shows positive oxidation state. Okay, because the fluorine is more electronegative than the oxygen, and due to that reason, when fluorine and oxygen are making compound, in that case the fluorine is negative oxidation state and oxygen in the positive oxidation state. So for oxygen, when it is -1, it is called peroxide. When it is -half, that is superoxide. When the oxidation state of oxygen, that is -1, then it is called peroxide. When the oxidation state of oxygen, that is -half, then it is called superoxide. When the oxidation state of oxygen, that is +1, that actually observe in O2F2, dioxygen difluoride, and the oxidation state of oxygen, that is +2, all are in positive oxidation state with fluorine. So when the oxidation state of oxygen, that is +2, the compound is known as the OF2, that is oxygen difluoride, monooxygen difluoride. Okay. So the maximum valency of oxygen, that is 3. The example is the H3O+, that is the hydronium ion. So that is the maximum valency in case of the oxygen, and others maximum valency, that is 6. So in group 16, the maximum valency of oxygen, that is 3, and for the other congeners like sulfur, selenium, tellurium and polonium, the maximum valency, that is +6. The first electron gain enthalpy, that is negative, that is exothermic. So the trend, that is actually first one, that is the sulfur, next selenium, next tellurium, next polonium, and then oxygen. Okay, so that is the first electron gain enthalpy range, and that is in negative sign. That means that is exothermic in nature. So students, you don't look at that order, just you look at this order. This order is correct here, and the values of the sulfur, that is -200. In case of the selenium, that is -195. In case of the tellurium, that is -190. In case of the polonium, that is -174, and in case of the oxygen, that is -141. So that's why the first electron gain enthalpy, all are negative, that means all are exothermic, and the actual trend that actually shows here. Okay, so that is the trend of the first electron gain enthalpy in case of the group 16 elements. And the second electron gain enthalpy, that is all are positive. Okay, and so that's why that is endothermic, and the actual trend, that is oxygen, sulfur, selenium, tellurium and polonium, that is the second electron gain enthalpy of a group 16 element. So that is the decreasing order of group 16 elements with respect to the second electron gain enthalpy, and all the values are positive. That's why that is endothermic process. But in case of the first electron gain enthalpy, that is exothermic in nature. Next basic idea I want to give, that is about the allotropes. All the group 16 elements exhibit allotropy due to the difference in the crystal structure, difference in the atomicity, difference in the extent of polymerization. So all the group 16 elements exhibit allotropy due to the difference in crystal structure, the difference in atomicity, the difference in extent of the polymerization. In case of the oxygen, the two allotropes are there. The one is oxygen and another one is ozone. In case of the oxygen, that is stable, that is paramagnetic, and that is linear. Okay, but in case of the ozone, that is unstable, and that is diamagnetic in nature, and it has the angular structure. In case of the sulfur, it has so many allotropes. So among all the elements, sulfur has the highest number of the allotropes. तो पीरियोडिक टेबल में जितना भी एलिमेंट्स है, उसके अंदर सल्फर ऐसा एक एलिमेंट है जिसके अंदर सबसे ज़्यादा एलोट्रॉप्स होते हैं. ठीक है, सो सल्फर हैज़ द हाईएस्ट नंबर ऑफ allotropes in total periodic table. The first one, that is the alpha sulfur, that is also known as the rhombic sulfur, or that is in octahedron structure. So it is most stable at room temperature. It is insoluble in water but soluble in organic solvent. Next one is the beta sulfur or monoclinic sulfur. That is also important, it's because mainly we are talking about in maximum cases, that is the rhombic sulfur and the monoclinic sulfur. So the rhombic sulfur, that is also known as the alpha sulfur, and the monoclinic sulfur, that is actually known as the beta sulfur or prismatic sulfur. So it is stable above 95.5 degrees centigrade. At 95.5 degrees centigrade, both alpha and beta sulfur are at equilibrium, that is the transition temperature of the sulfur. Okay, so at 95.5 degrees centigrade, both alpha and beta sulfur, they are situated at equilibrium. So that is the transition temperature of the sulfur. Next is the gamma sulfur or the monoclinic sulfur. Next one is the plastic sulfur. When the liquid sulfur poured in water, it forms the plastic sulfur. Okay, so how it forms the plastic sulfur? When the liquid sulfur, when we liquefied the sulfur and when we pour that liquefied sulfur into water, it forms the plastic sulfur. So alpha, beta, gamma sulfur contains S8 rings, means the rhombic, and the monoclinic sulfur, they contains S8 rings, means they are octatomic in nature, and that's why that is crowned in shape. The oxygen and sulfur shows the catenation property. The sulfur has the maximum tendency. Okay, in case of the oxygen and sulfur, both are showing the catenation property, and sulfur has maximum tendency of catenation property. That's why it forms the S8 moiety. Okay, so sulfur can form the chain with 10 sulfur atoms, that is H2SN, where N is equal to 2 to 10. Oxygen can form only the peroxide, that is H2O2. In case of the selenium, the 6 allotropes are there, 3 red non-metallic forms, that is SC8 ring, 2 grey metallic forms, and 1 in amorphous forms. So in case of the selenium, all total 6 allotropes are there. In case of the tellurium, 1 metallic and 1 non-metallic allotropes are there. So altogether only 2 allotropes are there in case of the tellurium, and in case of the polonium, the 2 metallic, that is alpha cubic and beta rhombohedral, these 2 types of allotropes can be observed. Now we are going to talk about the hydrides of the group 16 elements. So in case of the group 16 elements, the hydride can be written as H2N. For example, H2O, that is water, H2S, that is hydrogen sulfide, H2AC, hydrogen selenide, H2T, hydrogen telluride, and H2PO. So like that. So these are all the hydrides, all are the hydrides of the group 15, and all the hydrides, that is H2N hydrides in case of the group 16 elements, these are covalent in nature. Okay, so these are covalent in nature. Except water, the other hydrides are poisonous gas with unpleasant smell. So except water, other hydrides like H2S, H2AC, H2T, H2PO, they are poisonous gas with unpleasant smell except water. Everybody we know about the water, so I don't want to discuss anything about the water. Okay, so that actually we covered in our class 11 portion. Next, that is the thermal stability. The thermal stability of water is maximum, then H2S, then H2AC, then H2T, then H2PO. The main reason of thermal stability that is actually higher in case of the water, the main reason is that is the hydrogen bonding. Everybody we know that in water the hydrogen bond is there. So for that reason it is very stable in nature. But H2S, H2AC, H2T, H2PO, these are all gaseous, and the thermal stability is decreasing if we go from top to bottom along the group. The boiling point that actually decreases from H2O to H2S and then increases. Okay, so the boiling point of water, that is very high, but the boiling point of H2S, that is less, and then it again increases. So for that reason I had written that the boiling point in case of the H2S, that is very less, and the boiling point of H2O, that is high. Okay, so that is the trend of the boiling point, and the other elements are there, that is H2SE, H2T and H2PO. So that is the main trend of the boiling point. The highest means the anomaly is there in case of the water only. Okay, if you place the water just at front of just before the H2S, then that is in normal trend, but water is there which is going at first, means the boiling point is maximum. That is the main thing, and the reason of that is the hydrogen bonding in case of the water molecule. Next is the volatility. The volatility, that is also maximum in case of the H2S, then H2SE, then H2T, then H2PO, and then the less volatile, that is the water. So just the order, the boiling point order, just reverse is there in case of the volatility. What is the order of the reducing power and the acidic nature? The water that is least acidic in nature, and the reducing power of water, that is also less. And after that H2S, H2SE, H2T and H2PO is there. So that is in normal trend. So that is the order of the, that is the increasing order of the reducing power and the acidic nature of group 16 hydrides. Next, the heat of formation, that is delta H formation of water and H2S, that is negative, that is exothermic in nature. But when we want to form the H2SE, H2T, H2PO, the all are endothermic in nature, means during the formation of these hydrides the energy is released. Okay, so that's why the delayed formation of H2SE, H2T, H2PO, that is positive, but the delayed formation of water and H2S, that is negative, that is exothermic. All the hydrides have the bent structure. If I want to look at the structure of the hydrides, then everybody will know that when the water is there, in case of the metal, in case of the M, if I want to replace it in oxygen, so it forms water, and we know that the angle in case of the water, that is 104 degrees. But for others, means the for other hydride like H2S, H2SE, H2T, H2PO, the bond angle, that is almost 90 degree. So in case of the H2S, the angle is 92 degree, and in case of the H2SE and H2T, the angle is almost 91 degree, and in case of the H2PO, the angle is 90.5 degree, and in case of the water, at first we had already told that the angle is 104 degree. So the bond angle order, that is first of all water, that is 104, then H2S, that is 92, then H2SE and H2T, that is around 91, and then after that H2PO, that is about 90.5 degree. In water, the oxygen is sp3 hybridized, but for the others, means H2S, H2SE, H2T, H2PO, the pure p orbitals are participated in the bonding. That means the hybridization in sulfur, selenium, tellurium or polonium in their hydrides, that is p3 hybridization. Okay, in case of the oxygen, the hybridization is sp3, but in case of the others, the hybridization is only p3. There is no involvement of the s orbital. The oxygen and sulfur form less stable polyoxides and polysulfides like H2O2 and H2SN, where N is equal to 2 to 10. So oxygen and sulfur, it forms less stable polyoxides. So everybody will know that the hydrogen peroxide, that is very less stable, like that H2S2, H2S3, H2S4, these are also less stable polyoxides and polysulfides. So these are also hydrides. H2O, it can be prepared directly from hydrogen and oxygen, but H2S, H2SE, H2TE prepared by the action of acids on metal sulfides, selenides or tellurides. Like if I want to synthesize that H2S or H2SE, then we have to react the acids with the metal sulfides or metal selenides or metal tellurides. Like that, for example, suppose I have FeS, that is the ferrous sulfide. When it reacts with H2SO4, it forms FeSO4 plus H2S. So that is the main synthetic procedure for the H2S. And if we want to synthesize H2SE, we have to give aluminium selenide, that is Al2Se3 plus HCl, then it will give H2SE plus AlCl3. Okay, so that is the synthetic procedure for the synthesis of H2S or H2SE or H2T, but water, it can be prepared directly from hydrogen and oxygen. Okay, so this is all about our hydrides of the group 16 elements. So in our today's class, we have mainly discussed about the physical properties of the group 16 elements and the hydrides of the group 16 elements. So in our next class, I will discuss about the halides of the group 16 elements, and after that the oxides are also there. Okay, thank you.